Hi guys, welcome to week 6 of home learning. This week we will be continuing with topic 3 of unit 1, metabolic rates. Last week we looked at different organisms and the different metabolic rates they have and how their structure of their heart then affected how efficient their metabolic systems were, and the difference between different organisms who had a high metabolic rate requirement or who had a low metabolic rate requirement. This is the second part of that topic, and it should be quite a short lesson, hopefully. This week the learning intentions are to understand what measurements are needed to compare these metabolic rates. So if you wanted to look at different humans or different fish and so on, how then do you compare their metabolic rates? You need to be able to describe different apparatus that are used to measure the metabolic rate, and then one in particular, you need to be able to explain how to use a respirometer to measure metabolic rate. Again, this respirometer section, this will be covered much more widely in topic 2, cellular respiration. So I will go into it, but it will be pretty basic, the experimental questions I ask. As once we're back in school, this will be a topic that will be covered in more detail then. Okay, so let's get started. So how to measure metabolic rate then? Okay, I just want to give you a little recap from second year respiration. Anybody that did do National 5 biology, you should understand respiration a bit more. But this is certainly all you really need to know from this. So from S2 respiration, every cell in our body, which is on the main screen, you can see the little black nucleus in it. That's just an animal cell. Every cell in our body needs to respire. Okay, you need to take in food to then produce energy to carry out all these different processes that your body does. In order to do respiration, you need to take in two things: glucose and oxygen, and you then give out two waste products, carbon dioxide and water. Now, the glucose and water, you can be aware of them, but we don't really need them for this lesson. The thing that I really want you to think about is that each animal cell in our body, we need to take in oxygen in order to respire. So if you're taking in lots of oxygen, that shows that you have a high respiration rate because you're taking lots of oxygen in to then make lots of energy. And another factor which can be shown that you've got a high respiration rate is if you're giving off lots of carbon dioxide, the waste product, because we only give off this carbon dioxide, the waste product, when our body is doing this respiration process. Okay, so I just want you to think about oxygen is what is taken in during respiration and carbon dioxide is taken out. And if lots of oxygen or lots of carbon dioxide is taken in or given off, that is an indicator that lots of respiration is happening to that organism. Okay then, so metabolic rate, last week we discovered that metabolic rate is the energy consumed by an organism per minute. This week now we're going to look at, well, how do we measure that? There's 3 ways that we can measure the metabolic rate of an organism. One is how much oxygen they consume, which we've already explained, because that is an indicator that they're doing lots of respiration. The second one, again, we've already spoke about, is carbon dioxide produced. And the last one that we've not really spoke about is how much heat they're producing. Okay, so giving off heat is an indicator that an organism is going through a high metabolic rate at that moment. So in order to then measure metabolic rate, we have different devices to do so. Okay, so on the diagram, you probably see is it Mo Farah, I think, the runner. Okay, and on that, what he's doing is he's doing a little, this is kind of the things you would do if you're a sports scientist and stuff, maybe for an athlete or a footballer and so on. So he's in a room, he's on the treadmill running, and while he's doing that, he's got little probes linked up to him. Anyone that's maybe been in hospital before or anything like that would have had these on them before. They're little oxygen probes. It's like a little sticker kind of that sticks on you in certain parts of your body, and that can measure how much oxygen you are taking in or how much carbon dioxide you're taking out. Okay, so if you wanted to measure metabolic rate, one of the ways could be oxygen probes to measure oxygen consumption or carbon dioxide probes to measure carbon dioxide production. Another way to measure metabolic rate, which should be rather brand new to most people, is a calorimeter. Okay, and the way a calorimeter measures metabolic rate is by the amount of heat that a person is producing. Okay, so the way it works is you've got a little room like so. Okay, and the room is generally insulated. In that room, you've got your person. This person seems to just be sitting down, so I'm assuming their metabolic rate wouldn't be too high. But essentially what's happening is, if you look at the top of the diagram, you can actually see like a wire tubing, okay? Now, if you were in this sort of room, you wouldn't look up and see all these pipes. Obviously, it would be camouflaged and so on. But essentially what happens is water is fed in through the pipes at one end. So if you can see to the left-hand side, it says water in, and then at the other side, the water comes out. Now, the water that goes in, that is at a temperature which is recorded. And the idea is that if the person's in this room, maybe if they were on the treadmill or boxing or rowing, doing any sort of exercise activity, they would be giving off heat. That heat would then in turn heat up this water in these pipes, and then the water would come out at the other end warmer. And the way you would measure the metabolic rate is just the change in the two different temperatures. So for instance, if the water going in was 10 degrees and the water then coming out was 30 degrees, the change in temperature would be 20 degrees, okay? And the higher the change in the temperature, that shows that more heat is being given off, which means that that person has got a metabolic rate. Okay, so we've looked at the first devices. So you've got your oxygen probes, your carbon dioxide probes, and your calorimeter. They're pretty basic. And as I said, we will get into more details about experiments using them. But the one that I kind of want to concentrate on today, which is probably the most important one, is the respirometer. Again, if you'd carried out National 5 biology, you should have seen this sort of apparatus work. Generally, it doesn't work that great. So it's almost one of those things where you bring the experiment and people get really excited because you've got little wood lice or ants and stuff, and then there's not actually that much to observe to see. Okay, but essentially the last device used to measure metabolic rate is the respirometer, and the respirometer is used to measure oxygen uptake. Okay, so I've got a diagram on the screen here, and I'm just want to talk you through this. Okay, so if we start off at the left-hand side, at the bottom of the beaker, you will see there's a solution used to absorb carbon dioxide. Now, this apparatus is used to absorb oxygen uptake. Now, remember, the little snail in here will be taking in oxygen as it will be respiring, and that's what we want to measure. But remember, at the same time, it will be giving off carbon dioxide. So this solution here is needed to absorb any of that carbon dioxide gas in order for the experiment to work properly, for us to be able to measure and record how much oxygen's been taken up. Okay, so you've got your little snail, which is your living organisms. Sometimes you get germinating peas. Remember, peas are living organisms as well. Sometimes you'll get crickets, sometimes it'll be ants, sometimes it can just be yeast, you know, the liquid. Again, it's a living organism. So the organism can vary, but for this one, the diagram is a little snail. So the snail is the organism that's taking in the oxygen, giving off the carbon dioxide. We've got a little rubber stop on there. Obviously, that's because we want to see how much oxygen the snail's using up. We don't want the oxygen just to escape. And we've got a little tap at the top. That tap's usually open sometimes to allow the organism to get some oxygen to begin with. And then you've got a glass tube going all the way from the beaker right into a coloured liquid, and on this coloured liquid there's a snail. So the idea is that as this snail is taking in oxygen, eventually all the oxygen gas will be taken up from the little beaker, and because the carbon dioxide is sucked out, what will then happen is the snail, as it keeps taking in the oxygen uptake, it will essentially draw the colour liquid up the tube in order to replace that lost gas. And depending on how far that colour liquid tube, we can then use that to determine how quickly respiration rate happens. Now, you'll very rarely be asked to do this and work that out. You would always be given this scenario and then given a diagram and a table with the results in it, and it would say, you know, maybe what was the highest respiration rate, how many minutes, and so on. Okay, but I just want to explain that diagram to you a little bit. Okay, now, because of respirometers, they very often come up in the exams or check tests and stuff in experimental questions. Now, we did take the decision not to go into much detail in experimental questions just because it's something that will be done better when we're in class. But I do want to introduce you to some of the terms, and to be fair, you should already know quite a few of these terms from your assignments, either in chemistry or biology, or certainly my National 5 class, we were doing lots of experimental work. There was definitely experimental work in your prelim and so on, so this is a continuation of it. I am going to keep it really simple and only introduce a few of the terms, and the more difficult ones we will wait till we get back to school. Okay, so independent variable then. What is an independent variable? The way I remember it is independent variable is the thing that I am changing in the experiment. So there is only one thing that you can investigate in an experiment. Okay, so at the start of your experiment, you might want to say, right, I want to figure out how temperature will affect the respiration rate of a cricket. Or I want to decide, well, actually, I want to decide, does the type of organism affect the experiment? The respiration rate of the organism. So some of the things that you could be investigating is time, temperature, type of organism, number of organisms, or even the diameter of the tubing. Okay, so does that affect it? Okay, so the second thing I want you to be aware of is the dependent variable. The dependent variable is always the thing that you are measuring. Okay, so in an experiment into the effect of temperature, so temperature would be your independent variable, and how that affects the rate of respiration. So the dependent variable is the rate of respiration. However, a lot of time people get mixed up and they think, well, actually, it's the distance the dye moved up the tube or the time the dye took to move up the tube. That's wrong. That's an indirect measure. So essentially, the distance that dye has moved will then indicate us the rate of respiration. Okay, and I will explain that in a bit more detail as we go on to the next slide, okay? But independent variable is always the thing that you're changing in the experiment. Only one thing should be changed, one variable. And the dependent variable is the measured component of it. And when we're looking at respiration, it's normally always rate of respiration. Okay, so I just want to get into this in a bit more detail. Now, if you were to have an experimental question, which you do have in your assignments this page and assignments this week, you will always get an aim. So the aim is what's the purpose of the experiment? Why are you doing it? Now, the aim of this experiment is to investigate the effect of temperature on the rate of respiration. So we want to figure out, well, how will temperature then affect how much these little worms respire? Does that have an effect on it? Okay, so I want to get into this a bit more detail. So independent variable, the thing that's been changed in this experiment is temperature. And a big hint is it normally always comes after the effect of change in temperature. And the dependent variable is the measured, which is the rate of respiration. Okay, so again, you will need to look at these slides as you're answering these questions. Again, anyone that had me last year for National 5, you will have, I put an investigation help sheet on the system. I am also going to add that onto this week's assignment. Okay, now there's loads of information on it. We're only looking at independent, dependent variables and so on, but I will put it on there just that you've got that. But you must know independent and dependent variable. Okay, and the indirect measure is the rate of dye movement. You'll never really be asked that. I've not seen that in a long time coming up in a test, an exam or anything. But the problem is lots of people will put that down for the dependent variable when it isn't. Okay, so time or rate of movement or how many meters or centimetre the dye moved, that isn't actually dependent because that isn't what's the aim of the investigation. The aim of the investigation isn't to investigate the effect of temperature on how much the dye moved. Okay, it's on the rate of respiration. Okay, so I just want to make you aware of that as well. Okay, right, how does this work then? So oxygen's drawn up the tube. Respiration, it causes the coloured liquid to move up and replace the volume of gas loss as the carbon dioxide is absorbed. Now this question comes up quite a bit and it will say, can you explain the movement of dye in a respirometer? Okay, and in your own words, you just need to explain that the oxygen, the little respiring organism is taking in oxygen. It causes the liquid to move up and replace the volume of gases lost, and this is only able to happen because we have a solution. Sometimes it's called sodium hydroxide, or sometimes it will just say solution that absorbs the carbon dioxide. Because remember, if you don't do that, you won't. Essentially, the coloured dye won't move because you'll have that carbon dioxide gas in there. So we need to displace that. We need to remove that as well. Okay, and again, this is just a little recap on it. This is probably your textbook answer for it. So it'll say the use of the chemical to absorb carbon dioxide is very often sodium hydroxide. Animal uses up oxygen if container is sealed. The exhaled carbon dioxide from the organism is absorbed, forcing the liquid up the tube to replace the volume of gas. So that little slide there, previous slide there, is rather important because that question does come up quite a bit. Right. Now, another one, what other variables need to be kept constant? And again, this question is coming up in this week's assignment. So, as I've mentioned, your independent variable is the only variable that will be changed in the experiment. Every other thing in that experiment must be kept identical. And probably from first and second year, you would say to make it fair, okay? To make it a fair test. So, they must be kept constant. Some of the things that you could look at as a type of organism: the diameter of the capillary tube, the volume of the sodium hydroxide, the temperature, pH, concentration of sodium hydroxide, volume of liquid, and so on. So what the big thing is though, if your experiment question anywhere in your diagram or anywhere in the passage already mentions something. So if your experiment says that they were using crickets, then you know that it's all going to be crickets. If it mentions the temperature was kept constant at 10 degrees, then you can't mention that because the experimental question has already mentioned it. So don't just dive in and tell me anything that needs to be changed. Think about things that need to be kept constant, but then look at the diagram or look at the passage and say, well, they've not mentioned it. So it will always say in your question that has not already been mentioned. Okay, so that's where people go wrong there. And it's just things that, you know, if you're going to have more volume of sodium hydroxide or the concentration of things going to be more, that would affect it. If one of your experiment has 5 crickets and the other one only has 1, that would affect it. Because the more crickets you've got, the more respiration, therefore the more oxygen they're uptaking because there's more of them. Okay, so does that make sense? So it's things that need to be kept the same so that they don't affect your experimental results. Okay, and very lastly, why do we wait 10 minutes? So why do you let that oxygen in there for 10 minutes? And it's to allow the animals to adjust to their surroundings. I do not want anyone writing adapt. Your animal isn't adapting. It's not going from a cricket to 5 crickets, or it's not going from a cricket to a worm. That's adapting. It's just adjusting to its surrounding. It's allowing it time to adjust, take in the oxygen, and actually carry out the experiment. Okay, now guys, there is loads more experimental questions, but as I said, I just want eases in nice and slowly today, talking about the respirometer and some of the questions that you will be asked in regards to that. Okay, so one last little thing is numeracy questions. Now, don't panic, it is very simple numeracy questions. So sometimes very often you'll be asked to work out the metabolic rate of an organism's. So organisms all have different weights. So remember, again, if you're looking at a bear and a cricket, that's going to be completely different because of their weight. So to compare different animals' metabolic rate, it is important to divide by their weight so their answer is comparable. Okay, and the little equation you need to know is you take the oxygen uptake, divide it by the animal's weight, and divide it by the time. Okay, so I'll give you a little example. So calculate the metabolic rate of a 5 kilogram fish that consumes 100 ml of oxygen over 20 minutes. So the way you would do that would be 100 ml divided by 5 divided by the 20 minutes, and you should get 1 ml per kilogram per minute. Now these units are important because when you're asked this question in biology, we always give you the units. So even if you forget the order, if you forget that it's 100 ml divided by kilograms divided by time, don't worry, always look at your wee unit and I'll give you a wee hint. Okay, so that's just a little tip there to remember. These questions are very basic, but I have put one of these in your assignment this week as well. Will you get asked this in the final exam? I'm not sure, but it's just something that we need to cover. Okay, so certainly. And that's it for this week. So it should have been short, but we still ended up about 20 minutes. So how would you be successful in this week's lesson? To describe the measurements used to compare metabolic rates, to describe the different apparatus that use, and to explain how to use a respirometer and how to then measure metabolic rate using those little calculations. Okay, so next week, guys, it will be check test 2. Again, it'll be a revision catch-up week. There is still some work outstanding by some people. I am giving feedback on Teams, so whenever you submit an assignment, even if you don't submit an assignment on Teams or you don't click hand in and you email me, don't worry, I hand it in for you, I do that for you, and then I give you feedback, and I've got a lovely colour-coded spreadsheet with everything that's handed in for everyone. So if you are in doubt about anything being handed in or anything, just drop me a wee email and I can let you know. But when I am giving you feedback, if you do have anything outstanding, I will say it at work. Also, next week, I'm probably going to give you another essay. That was similar to the other week. We had a 4-mark essay comparing anabolic and catabolic reactions. It was done amazing. Don't overthink these essays. They're not English essays, okay? As long as you get 4 marks, 4 facts down, you generally get the work. Okay, so well done and another good week last week, guys, and enjoy this week. Again, any questions, any issues, drop me an email at any time. Bye.